Welcome and good day everyone. Today we will tackle about the Chinese Remainder Theorem or CRT. So before we delve into the example 1 and example 2 to our topic, I will tackle about the history of the CRT. So, CRT or the Chinese Remainder Theorem, it is a result in number theory with origins in ancient Chinese mathematics. It provides a way to solve systems of simultaneous congruence with pairwise comprime moduli. So, here is the breakdown of its history. So, during the 4th to 5th century AD, Sun Zi's Wanjing, the CRT or the Chinese Remainder Theorem appeared in the Chinese mathematical text Sun Zi Xuanjing or Master San's Mathematical Manual. During the 3rd century AD, although Liu Hu predates Sun Zi Xuanjing, his work on modular arithmetic laid the foundation for later respondents in Chinese mathematics. Later on, the Chinese mathematicians such as Qin, Zhu Shu Hao in the 13th century expanded on modular arithmetic concepts in their works, especially in solving polynomial congruences. And during the 17th to 18th century, the CRT became known in Europe through translations of Chinese texts and later independent discoveries. And during the present time, which is the 20th and 21st century, the CRT gained practical importance in computer, science, cryptography, and coding theory due to its efficiency in modular computation.
Of examples so that we can more understand what is the Chinese remainder theorem. So, open this please. So the Chinese remainder theorem is used to solve a set of different congruent equations with one variable but different moduli which are different prime as shown below. So these three is we should follow this because it is the formula on how to solve the Chinese remainder theorem. And CRT states that the above equations have a unique solution of the moduli are relatively prime. So this is the formula of the final equation of the Chinese remainder theorem. So now let's have an example first. Let's open this. So, first example is we have x is equal to mode 3, x is equal to 3 mode 5, x is equal to mode 7. So first we will get the mode or the bigger m. So in order to find the bigger m, the formula is m is equal to mode 1 times mode 2 times mode 3. So the representation of each mode, capital M, is 3, 5, and 7. So 3 times 5 times 7 is equal to 105. So first now let's go to the bigger M mode, which is mode 1, 2, and 3. First S is mode 1 is equal to mode M over mode 1. So our mode M is 105 over the mode 1 which is equivalent to 3. So 105 divided by 3 is equal to 35 and so on and other one. And then the final is
M1.
in order to find that this is the way how to find is mode 1 times mode inverse 1 is equal to 1 mode M1. So our mode 1 is 35 times mode inverse is wala pa man siya nakita, so atong equals to 1 mode 3. So 35 times 2 nganong nakakuha tag 2 no kay kaning to is kuan gid siya, mag-try and error gid siya until ma-remainder siya og 1. So atong gitryan og 2, mo equal man siya og remainder 1 man siya. Muna atong mode inverse 1 is 2 until sa mode inverse 3.
Ano ka?
Then the last problem to solve is ato na siyang i-substitute tanan. Muna siyang makuha na to muna ang formula to is x is equal to a sub 1 mode 1 mode inverse 1 plus a sub 2 mode 2 m inverse 2 plus a sub 3 m3 plus mode 1 inverse 3 and times mode m. So ang total niya is muna siyang 23. This one 23 mode 5, so 233 rather, mode divided by 105, mukuha siya og 23. So that's all.
So for the second example, we have two congruent equations. First is 4x is congruent to 5 mod 9 and 2x is congruent to 6 mod 20. So here we can see that it's kind of a little different from the first example since here natay 4x and 2x. So in this example, we have to apply a little bit of a trick. And first, what we're going to do is to rewrite the equation. So here, as you can see, di ba, if ganahan ta nga ang x na lang ang mahabilin, aning equation, we have to multiply each side with 4 inverse. So by multiplying 4 inverse each side, di ba, 4 inverse times 4, obviously, we've got the x na lang equals to 4 inverse mod 9 times 5 mod 9. So here we can see nga ato siyang gi-apply ang mod 9 since ang mod 9 applicable man sad siya sa 4 inverse. So we have to solve what is 4 mod 9. So atong buhatan ana is we have to find the multiplicative inverse or mingita tag number nga once ato siyang i-multiply sa 4, ang iyang answer, iyang product, if i-divide na to og 9 mo remainder 1. So nag-try ta from 4 until 6, di man siya pwede. So pag abot og 7 dito na ta since 4 times 7 makakuha man ta og 28. So 28 divided 9 makakuha tag 3 times 9 27. So maka-remainder 1 ta. Therefore ang multiplicative inverse sa 4 mod 9 is 7. 7 then copy 5 mod 9. So here 7 times 5 we've got 35 mod 9. So here pwede na nato magamit na jud ang 35 mod 9 but pwede pa man siya ma-reduce. So ato siyang reduce into 8 mod 9. So pwede siya magamit duha but it is recommended nga gamiton jud nato ang reduced form. So next. So here we've got our formula, which is, since two equations naman atong gamiton is ang x equals a1 capital M1 inverse plus a2 capital M2 inverse mod m. So from that, gikan sa atong mga pag-solve, nakuha na dyan na to ang given sum kaning a1 is equals to 8 as shown before, a2 is equals to 3, small m1 is equals to 9, and small m2 equals 20. But as you can see here in the formula, wala pa na to nakuha ang value sa capital M1 inverse, capital M2, and capital M2 inverse. So, mo na siya atong buhaton karon. So, we have to find their values. First is ang pagkuha sa capital kaning sa M. So, atong buhaton is to asa dapat ito? Is to multiply the small m1 and the small m2, which is 9 times 20, and we've got 180. So next atong buhaton is to find the capital M1. Ang formula niya which is to m kani siya over m1. So 180 over 9 is equals 20. So we've got the answer now. Similarly with m2, we have to divide 180 over 20, then we got 9. So now we have to find the M1 inverse. So unsa matong buhaton, we have to multiply the capital M1 times capital M1 inverse equals 1 mod small m. So ang pasabot ana M1 naman na naman tay 20, we have to find a number nga maka-result og answer nga once i-divide na to og 9 mag-remainder 1. So here we've tried numbers pero sa 5 ra jud 5 nato na siya na find ang answer. So 20 times 5 equals 100, divide 9, we have get 11 times 9 99, so more remainder siya 1. Therefore ang atong capital M1 inverse is equals to 5. Same sa ato ang sa M2 mo ra gihapon atong buhaton, we have to find a number nga once ato siyang i-divide og 20 more remainder into 1. So here we've got 9 man atong M2 and 9 times 9 81 divided 20. 20 times 4 is 80, so maka-remainder ta og 1. Therefore, ang ato ang capital M2 inverse is equals to 9. So, since nakuha na nato ang tanan nga value, mo return na ta karon sa atong formula to substitute the values. Here, we've got the final solutions. X is equals to 8, mga atong A1 times 20, capital M1, times 5, which is capital M1 inverse, plus 3 atong A2 times 9 capital M2 times 9 capital M2 inverse mod 180. So here ato na siyang multiply and add. We've got 800 plus 243 times mod 180. So ato siyang gi-add, we've got 1043 mod 180. So 1043 divide 180, makakuha ta og remainder 143.